Evaluate the integral of 10 over x squared minus 25 from 3 to 4. The first key to recognize is that this is not trig substitution. I mean, it looks like you see x squared minus a squared and you're thinking trig sub. But no, it's not. Maybe if it had been, underneath a root, or perhaps if there was a plus sign, you could go there with it, or maybe, some fractional power, but not by itself like this. By itself like this, with the minus in between there, that is the difference of squares. X squared minus 25 is the difference of squares. It can be factored. Okay, so this is a partial fraction decomposition question. Check to see if the denominator degree is higher than the numerator degree. It is. So then you begin the method by factoring the denominator. This denominator factors is x plus 5 and x minus 5, the difference of squares. Now the key is that you need to recognize which of the three types of terms you have. The three types are linear terms to the first power. The second type is linear terms to a higher power, a degree higher than one, a power higher than one. And then finally, the third type is an irreducible quadratic term. So we're looking at x plus 5, x minus 5. These are two terms that are linear and they're to the first power. It's important you recognize that because that'll tell you how to decompose it. So that's our job. Now decompose it. So how does it decompose? Well, when you have linear terms to the first power, you just have a fraction for each one. So a over x minus 5 and b over x plus 5. Okay, great. Now we're going to use algebra to track down these constants. What we could basically do is focus our attention on the numerators. If we were to take and put this fraction a over x minus 5 and b over x plus 5 together, we'd have a times the quantity of x plus 5 and b times the quantity of x minus 5. This is the term that they're missing in order to get the common denominator. And this 10 is the original original numerator, sorry. So we have our original numerator, and then we have our numerator that we would get once we put these fractions together. We can focus our attention right there. And basically what we need to do is to recognize that this is true for all values of x. So we'll pick x smartly. The smart choice of x is x equals 5. Any choice of x that would make your denominator 0, these original denominators, that would make them 0 is good. Not that having a denominator 0 is good, it's that there aren't even any denominators in this. It's just the fact that it'll kill a term. If you let x equal 5, plugging it in will make the b term go away because it'll be times 0. And you'll be looking at 10 equals 10a. And then you know a right away, that a is 1. So the next smart choice for x would be x equals negative 5. Plugging that in, you'll kill the a term because it'll be 0 for its coefficient. And you'll have 10 is negative 10b. So you'll have that b is negative 1. And you have your constants. Now the next step is to put it all together and then integrate. Above x minus 5 was an a, and above x plus 5 was the b. So we put them in, and now we're ready to integrate. The integration is harmless. Here's the one line of calculus. We're to integrate this, and these are just natural logs. Don't forget the absolute value, though. We'll have the ln of x minus 5 in absolute value, and the ln of x plus 5 in absolute value. The minus comes from the fact here. We could have made it subtraction and then, but I made it plus and minus here. So that's a negative. Now where we go from here is up to you. You need to make a decision on how you want to end this problem. The first thing we're going to do is think about it is if we don't combine these into one log. Like right now, we have log of a minus log of b. We could combine them into a log. Let's take a look at that secondly. So what we're going to do first is just leave them separate, put the 4 in, and then put the 3 in. You put the 4 in, Right place you see an x. That's the upper limit evaluation. Then you put the 3 in. Every place you see an x. And we get our lower limit evaluation. Sometimes this can be trouble, so you just want to be careful when you have the end of these problems. The absolute values are critical because here we have 4 minus 5. That's a negative 1. That would be trouble if you didn't put the absolute value sign. And so we're looking at the log of 1 minus the log of 9. And then over here we have the log of 2 minus the log of 8. This is going to be a negative 2 inside of here, but it's absolute value. Okay, this guy's the 9, and this guy's our negative 1. And you know the log of 1 is 0. So let's just distribute this negative across. And what we have is negative log 9 minus log 2, but then plus log 8. Okay. My advice here is to write this as some log A minus log B. So keep the log 8 in front and then factor the negative out of these two guys. So we'll have log 8 and then we'll have minus log of 9 plus log of 2 in parentheses. That way we just have a way to represent who's in the numerator of my fraction and who's in the denominator of my fraction. Okay. But before we do that, we can put these two guys together into one log by multiplication. 9 times 2 will give you 18. And then we have log of 8 up top. So 8 over 18, or we can cancel here. I guess we didn't have to put them together. And we're looking at the natural log of 4/9 for your final answer. That's if you were to combine, or not to combine them, and to leave them separate. On the next slide, let's look at an alternative ending to this problem where we actually combine them. And you choose whichever way you need to help you understand how to work it out. So, alternative method, combine these guys into one log. So we have log of A minus log of B. We put these as one fraction, the log of x minus 5 over x plus 5. And then we plug into that. So 4 minus 5 and 4 plus 5. 3 minus 5 and 3 plus 5. And what we get, numerator here is a negative 1, denominator here is a 9, numerator here is a negative 2, denominator here is an 8. So we get negative 1/9 and negative 2/8. Inside absolute values, that's the log of 1/9. And we'll go ahead and reduce this guy and call it the log of 1/4. And they're subtracted. So we divide them in one log. But dividing by a fraction is multiplying by the reciprocal. And we get the same answer, natural log of 4/9. Okay, great.